if we have a function, as an example, f of xy, x squared y squared plus the square root of y sine x, and we want to examine its behavior in the neighborhood of the point pi over 2, 3. We calculate the x derivative of the function, which is 2xy squared plus square root of y cosine of x, so that fx at the point pi over 2, 3 equals what? 2x is 2 times pi over 2, that's just pi. Y is 3, y squared is 9. So it's 9 pi. And then plus the square root of y cosine x, well, y is 3. And the cosine of pi over 2 is 0, so that's the square root of 3 times 0, which simply then equals 9 pi. Now remember, this is the rate of change of f with respect to x at the point pi over 2, 3. Similarly, we can calculate fy and get the rate of change of f with respect to y at this point. So fy is, derivative of y squared is 2y, so we're going to have 2x squared y plus 1 over 2 square root of y sine of x. So that fy at pi over 2, 3 is what? We're going to plug pi over 2 for x. We're going to get pi squared over 4. Multiplying that by 2, we've got pi squared over 2 times 3 is 3 pi squared over 2, if I'm doing my arithmetic correctly. And 1 over 2 square root of y is going to be 1 over 2 times the square root of 3. And simplifying that, we get square root of 3 over 6, and the sine of pi over 2 is just 1. So this becomes square root of 3 over 6, which is 1 over 2 times the square root of 3, and you can rationalize that denominator if you wish. Let's approximate both of these values, and I don't think I need that anymore. I think we're in focus now. Okay, well, 9 pi is about 3, 9 times 3 is 27, and we got about actually 3.14, which is about almost 1/20th of pi. So if we increase that by 1/20th, it's going to be a little over 28, and I'm just going to be a little bit sloppy. So that's about 28. And this one, 3 pi squared, well, pi squared it is a little more than 9. Pi is about 5% more. That's going to be about 10% more than 9. This is going to be about 9.930 over 2. Say 15, and the square root of 3 is 1.732 over 6. That's pretty close to 3, so I'm going to say that's about 16. I'll put a question mark there because I really am doing that in my head. And that's clearly not right. I believe I forgot to multiply. Okay, pi squared is close to 10. That's about 30. No, that's about right. 30 over 2. Never mind. Thought I was wrong. Okay, so there's the fy and there's the fx. Now, what does this tell us about the picture of the function? Well, if we're on the point, let's just do this in the xy plane for the moment. Here's x, here's y. Pi over 2 is a little over 1.5, about a little more than half of 3. So let's just make y about twice as big as x and call this point pi over 2, 3. Now, if we move in the y direction, so moving in the y direction, the rate of change of f with respect to y, a little bit redundant saying with respect to y because I did say in the y direction, but let's be careful. Rate of change of f with respect to y is approximately 28. So for every unit we move in the y direction, this function is going to increase 28 units. Obviously, if we were to graph this on xyz within an xyz coordinate plane, the function would be very steep at this point, assuming we're using equal scales for the x, y, and z. We'd have a very steep graph. This thing's going to go up very quickly. If we move a unit in the y direction, it's going to go up 28 units. And of course, this line segment represents motion in the y direction. This line segment represents motion in the x direction. So if we move along this direction, the y direction, we're going to go up 28 times as fast as we move across. Moving in the x direction, which is what we're doing here, holding y constant, moving in the x direction, rate of change of f with respect to x is about 16, which means that if we move a unit in this direction, we're going to come up 16 units in the z direction. That's pretty steep also, a little more than half as steep as this. So it's very steep here, but not quite as steep. And of course, we're just looking in terms of if we move in the xy plane, what kind of change is that going to induce in the value of the f of x function. For example, if I move 1/10 of a unit in the y direction, then we're going to move 1/10 of 28 units in the z direction, 2.8 units for every tenth of a unit, 1.6 units for every tenth of a unit in the x direction. We could ask the question, what happens if we move in some direction that's a combination of the x and y directions? I'll simply comment for the moment that if we don't move too far away from this point, these rates of change aren't going to change by too much. If we were at the point, let's say, pi over 2 plus 0.1 and 3 plus 0.1, when we evaluate the function, we are going to get something that's probably a couple of units different from what we have here as well as here. But it's not going to be a drastic change. So that these rates of change hold exactly at this point to the extent that these are calculated exactly, and they aren't. But the exact rates of change, 9 pi and 3 pi squared over 2 plus the square root of 3 over 6, would hold exactly at this point. And if we stay close to this point, they'll still hold approximately.